All right, let's jump right into a piece of trivia that is a real head-scratcher. Seriously, it's one of those facts that completely plays with your sense of scale and what you think you know about our own world.
So here it is, the question that's been floating around online. What's wider, the entire continent of Australia or the moon? Now, at first glance, it sounds like a pretty simple question, right? You'd think there's an easy answer, but as we're about to find out, the truth is, well, a lot more complicated and way more interesting.
Okay, first up, let's actually put this viral question to the test. We're going to unpack why the answer isn't a simple yes or no. It's actually a perfect example of how the way you measure something can change, well, everything.
So if we're just talking about a simple, point-to-point measurement of width, like with a ruler across a map, Australia actually wins. From its easternmost point to its westernmost, the continent stretches nearly 4,000 kilometers. The moon, on the other hand, has a diameter of 3,475 kilometers. So case closed, right? Australia's wider. Well, not so fast.
And this is where the whole perspective shift really kicks in. Because, yeah, Australia is wider, but the moon is a three-dimensional sphere. When you compare the total surface area, it's not even a contest. Australia covers about 7.7 million square kilometers, but the moon's surface is a whopping 38 million square kilometers. That's almost 5 times larger.
So it all just comes down to what you're actually measuring. The fact-checking site Snopes.com put it perfectly. They rated the claim as both yes and no, saying it depends on what yardstick we use. And that just brilliantly shows how a simple question can have a really, really nuanced answer.
But this little fun fact is so much more than just trivia. It's actually a gateway to understanding just how incredible our moon really is. So let's look beyond its size for a minute and explore the amazing story of our cosmic neighbor.
So, where did our moon even come from? Well, the leading theory today is about as dramatic as it gets. It's called the giant impact hypothesis. The idea is that around 4.5 billion years ago, some other protoplanet, maybe about the size of Mars, just slammed into a very young, still molten Earth.
Scientists sometimes call this crazy event the Big Splash. Just imagine, first, this massive object collides with Earth. The impact was so huge it blasted a ton of vaporized rock and debris out into orbit. And then, over thousands of years, gravity just slowly pulled all that material together to form the moon. I mean, what a violent birth for such a peaceful-looking object in our night sky.
And believe it or not, the drama between Earth and the moon isn't over. So what's this number, 4 centimeters? That's how far the moon is drifting away from the Earth every single year.
4 centimeters might sound tiny, but over millions and millions of years, it really adds up. This slow-motion separation is all because of the moon's gravitational tug on our oceans, the tides. This constant sloshing of water actually transfers a little bit of Earth's rotational energy to the moon, and that basically pushes it into a slightly higher and therefore more distant orbit.
So, how does our moon stack up against the others in our solar system? Well, by pure size, it's the 5th largest. But here's the really mind-bending part. Compared to the size of its parent planet, our moon is the largest by a long shot. No other major planet has a moon that's such a huge fraction of its own size. It's so unusual that some scientists even call the Earth-Moon system a double planet.
Okay, so that Australia moon thing really forces us to rethink our sense of scale, doesn't it? And if one of our continents can be compared to our nearest celestial body, it just makes you wonder, what other incredible surprises is our own planet hiding in plain sight?
First off, let's talk about Earth's shape. It's not a perfect sphere like a marble from your childhood. Because it's constantly spinning, centrifugal force causes it to bulge out a little bit at the equator and get a bit flatter at the poles. It's technically what's known as an oblate spheroid, kind of like a slightly squished ball.
Next, let's go deeper. Our planet's interior isn't some solid, static ball of rock. Scientists actually describe the mantle as having a squishy consistency. It's this semi-solid layer that flows incredibly slowly over millions of years, and this sluggish, powerful movement is literally what drives the continents around on the surface.
And here's a wild change that's happening right now, and super fast in geological terms. The magnetic North Pole, the thing your compass points to, isn't fixed. In recent decades, its movement has accelerated from a slow crawl into what scientists are calling a sprint, as it races away from its old spot over Canada and makes a beeline for Siberia.
So just how fast is a sprint for a magnetic pole? We're talking about 50 to 60 kilometers per year. That's a huge deal, and it has very real implications for all our modern navigation systems that rely on it, from from the compass in your phone to the complex systems that ships and airplanes use.
And the wonders just keep coming. Just think about this. Antarctica's ice sheet holds a staggering 90% of all the ice on Earth, and that ice holds 70% of the planet's fresh water. Meanwhile, in our warmer oceans, coral reefs form the largest living structures on Earth, so vast they're actually visible from space.
Okay, from Australia's width to Earth's squishy interior, we have covered a lot of ground. So for this last part, let's try to tie it all back together and think about what this new sense of scale really means for how we see our place in the cosmos.
I absolutely love this quote from NASA because it just grounds everything in an analogy we can all picture. If Earth were the size of a nickel, the moon would be about as big as a coffee bean. That perfectly shows their relative sizes and makes you appreciate not just the objects themselves, but the immense, empty space that separates them. And that's really the heart of it all, isn't it? We started with a simple, almost playful trivia question, but by digging into it, we uncovered some fundamental truths about measurement, about perspective, the violent history of our solar system, and the hidden dynamic processes of our very own planet.
Which brings me to a final question for you. After all this, after seeing how a continent can be wider than the moon, but still be dwarfed by its surface area, after learning our planet is this dynamic, squishy, wandering world, does our own world feel bigger to you now, or does it feel smaller? It's all a matter of perspective, and you know what? There's no single right answer.